All right, let's continue where we left off last time when my computer died. We were doing this equation. E to the power x cosine x dx. Remember, we're integrating by parts. Which means when we integrate by parts, we have to find these four pieces. Because the formula we'll be using is the integral of u is equal to uv time minus the integral of v du dx. So this is the formula we'll be using again. So looking at our example here, both of these will continue forever and ever and ever. So it's the easiest one. Call it e to the x. Remember, this is the u. That's the v prime. So that's cosine x dx. So we have to find these two, so we can plug in the rest. So the derivative of e to the x is e to the x. The integral of cosine is sine x. So according to this, it's u times v. U times v. So it's e to the x sine to the x minus the integral of v, which is sine x, times du, which is e to the x dx. This is dx. All right. So what do we have here? Leave the first part alone. E to the x sine x. Because we have this again, we have to integrate by parts again. So with this one, we have to find the u, v, du, dv. So again, we use e to the x as the u. So e to the x dx is the derivative. And we'll use sine x dx as the derivative. So the integral of sine x is negative cosine x. Right. So now we got to do the same thing again with that. So we have uv, which is negative e to the power x cosine x, minus the integral of v, which is negative cosine du. So it's going to be negative cosine x e to the power x dx. E to the x sine x. That becomes a plus. E to the x cosine x. That becomes a positive. That becomes a negative. So we have e to the x cosine x dx. E to the x cosine x dx. See now, at this point, if we only look at this side, we'll keep on going forever and ever. We'll just repeat this thing over and over and over. But because this equation looks like this equation, we can combine them. So if we add integral e to the x cosine x dx to both sides. Cosine x dx to both sides. This gives us 2 e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine x plus c, because that's the integral is equal to this. And we divide by 2. It's a constant, so it's already doesn't matter. So we have the integral of e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine x divided by 2 plus c. Yeah, so we just isolated that one variable. I mean, the one term. Right? Let's look at example 5. Okay, example 5. Obtain a formula that expresses the integral cosine nx dx in terms of an integral of a lower power. So we're using a power reduction process. So we want it to be a lower power of cosine x. Okay, so what do we begin with here? So we know that cosine n of x can be written as cosine x times cosine n minus x. We took away 1. Now, this is the whole process we're looking at. So this becomes cosine x cosine n minus 1x dx. So from here, we have to find, since it was a product, we have to look at by parts. So we have to figure out the u, the v, the du, and the dv parts. Remember, for the u's, we want it to be eventually that the derivatives will go down to 0. So that's why we'll have cosine n minus 1x. And for the dv, then, we'll use the cosine x. So the integral, the integral of cosine is sine x, and the derivative of cosine n minus 1 is, bring the power down, cosine n minus 2x dx. So this is my du, that's my u. All right, so now we can go ahead and do our formula, which was u cosine n minus 1x v sine x minus, hold it, I forgot the sine part. It'll be negative sine x dx. Because the derivative of cosine is negative sine. Okay, so minus the integral of du v. Oh my gosh, it'll be a big one. So it's negative n minus 1 cosine n minus 2x times sine x times sine x duv times sine x dx. All right, let me put down the formula again. uv prime equals to uv v du dx. Or u prime, I should say, not du. uv prime, uv, v, u prime. Okay, yeah. So we have those. So here's uv v du. All right, now we can go. Cosine n minus 1 x times sine x. This negative and that negative makes it a positive. So now what we could go ahead and do is we can distribute. Well, the n minus 1 is a constant. So we'll put the n minus 1 out in front here. So we have sine, sine, cosine. So it's cosine n minus 2x sine squared x dx. Okay, now it's gotten smaller. All right, since we have cosine there, so we have cosine n minus 1 x times sine x plus n minus 1. It's pretty much everything is written cosine. We know the identity of sine squared x is 1 minus cosine squared x. So we have cosine n minus 2x times 1 minus cosine squared x. Now we can distribute there. So we have cosine n minus 1x sine x n minus 1 cosine times 1 is cosine n minus 2x dx. And it's this whole, so it's minus n minus 1 integral cosine times cosine squared is simply cosine, because you add the exponents. N minus 2 plus 2 is just n. All right. All right, so let's see. On this side, we have cosine nx dx, and here we have a cosine nx dx. But it's also got a coefficient of that. Okay, so let's distribute this one. Okay, that's right. That's right. And if we move the whole thing over, then let's move this whole thing over. Let's give that coefficient. So we have cosine nx dx plus n minus 1 integral cosine nx dx is equal to cosine n minus 1x sine x plus this term, n minus 1 cosine n minus 2x dx. So we have a 1 in front of here. So they have 1 plus n minus 1, the integral of cosine nx dx. Sine x plus n minus 1 cosine n minus 2x dx. So the ones cancel, so we have n cosine n x dx is equal to the cosine of n minus 1x sine x plus n minus 1 cosine n minus 2x dx. So far, so good. Because this is where, so if we divide by n, then our formula becomes cosine n minus 1x times sine x over n plus n minus 1 and the integral of cosine n minus 2x dx. There is our formula. Because it has a power reduction. It's called a reduction formula. For example, so this is our formula. So for any n that you're given, let's say n equals 3. Now you could place an 3 in place of n everywhere, and you'll come up with a formula. I'll show you. Oh, I'm going to do n equals 3. So the integral of cosine cubed x dx is equal to cosine 3 minus 1x sine x plus 3 minus 1 over 3 the integral of cosine 3 minus 2x dx. So the integral of cosine 3x dx is equal to cosine squared x sine x over 3 plus 2 over 3 cosine x dx. Cosine squared x sine x over 3 plus 2/3 integral of cosine is sine plus c. Now we have a formula we can use whenever we need it. All right, let's go back to the example sheet. Let's see what. Okay, this is an example of evaluating an integral, a definite integral. Okay, so up until now, a definite integral. We're going to use the same formulas we had earlier. We had u of x v prime of x dx is equal to uv minus the integral of v of x u prime of x dx. All right. So this is what this new section, since we're dealing with, these are the indefinite integrals. We always had to have plus c. Now we're going to go from our bounds. This is the formula we'll be using for definite integrals. In example 6, it said, find the area of our function y equals x e to the power negative x between the x-axis and the function from x equals 0 to x equals 4. So this is our u and v. This is this part. This is a and this is b. So we're looking for our integral from 0 to 4 of our function x, where's it? X e to the power negative x dx. So here we have to do the u du part. So the x will be the easiest derivative. So the derivative of x is 1. It's just dx. E to the power x negative x dx is our v prime. The integral of that is negative e to the power negative x. Okay, so we can start looking at those. Now we have x negative x times e to the power negative x from 0 to 4 minus the integral from 0 to 4 of negative e to the power negative x times dx. So v is e negative x and du is dx. Let me write that on the other side, so I can keep on going. From 0 to 4 x e to the power negative x equals negative x e to the power negative x from 0 to 4 minus okay, this part's going to be just straightforward. So we have anywhere C and X, you put a 4. Minus anywhere you see an X, put a 0. That becomes a positive. We have negative 4 e to the negative 4th. That goes to 0. And the integral from 0 to 4 is negative e to the power negative x from 0 to 4. Minus, that was minus. E to the negative 4 minus e to the negative 0. This becomes 1. So we have negative 4 e to the negative 4 minus e to the negative 4 plus 1. These two can combine, so we have minus 5 e to the negative 4. All right. That does it for end of section 2. Now section 3. Yeah. Actually, I'll go ahead and put that there because I'm going to stop this tape here and start